Hello guys, in this video I'm going to show you how to solve median of sorted arrays, m sorted arrays. So this one is in k-way merge pattern. Given m sorted arrays, find the median number amongst all arrays, right? So for example, we have three sorted arrays in ascending order. You can see each array is sorted by itself, and our goal is to find the median numbers among all arrays. So what is the median number? The median number is the middle number when the array is sorted. So for example, we have an array 1, 2, 3. Let's say 1, 3, 9. Here is a sorted array, so the median is the middle number, which is 3. But here's the case, the number is the amount of number is odd, right? But if it is even instead, then in this case, there are 4 numbers in total. Then our median will be the average of 2 middle numbers, which is 3 and 4. So we have 3 plus 4 divided by 2 is 3 plus 5, right? So that is about median number, right? So our goal now is to sort all the array into one array, right? So that we can find the median. For sorting m sorted array, the approach is same as our previous problems in this category. So I'll guide you through this one again. So in order to but first, do we really need to sort the array? Probably no, because we only need to find the middle number, right? So how about just sort the half of the array? Here we have we know the total number of each array. It means we also know total numbers of all arrays. So for example, there are 9 numbers in all arrays. It means the middle number will be number 5, right? So that is how we can reduce you can optimize for iterations. So let's walk through our sorting algorithm. So in order to sort the 3 arrays into one array, one sorted array, we first We're gonna use a min heap, right, to always keep track of the so that we always have access to the smallest number. So the first set of values will be first three numbers, which is 2, 3, 1, right? So we always have access to the smallest, which is 1 in this case, right? The first set will be 2, 3, 1. So the sorted list will be the smallest number amongst all array will be 1, right? So we push 1 to the sorted array, then remove it from here. Our new smallest will be 2, right? So after remove 1 from min heap, wanna push the next number that is right after 1, which is 3 in this case. So we must have a way to remember each number, where each number comes from, right? Where each number in the heap comes from. So for example, when we remove 1 from the min heap, we must know 1 comes from L3, so that we can add the next number of 1 that right after 1 into min heap for processing, right? So now we push 3 to here. So 2 is the smallest number. We push 2 to the sorted array, remove 2. Now smallest is 3. So after remove 2, after remove 2, we push the next number, which is 6. Let's mark all the number that is in the mark sheet here. So we push it 6 here. Smallest still be 3. Okay. Then we push 3 to the sorted. Remove 3 from here. Then add the next number that drive the 3 to here. Okay, the smallest is now still 3, right? So again, add 3 here, remove 3, then add the next number after 3, right? To the min heap. The smallest now become 4. Now add 4 to the sorted, remove 4 here, and we're done with this, because there's nothing after 4 here, so we're done with the last array, right? So we have 2 elements left in a min heap. The smallest one is 6. Anyway, so probably we don't need to, as we discussed earlier, we don't need to sort all arrays, but just half the number of all arrays. So we have 9 numbers here, it means wanna sort until our sorted reaches length of 5, right? Which is in this case 1, 2, 3, 4, right? So the median group is the last number after we finish sorting, right? Okay, that's it for our algorithm. So let's try to code it all. Okay, first try to calculate the total number. Is I'm gonna use reduce functions, right? Reduce, let's go each subarray. The first is accumulator, the second is current subarray. Okay, each iteration gonna add up the subarray length to accumulator. Initially accumulator is 0, so this will give us total numbers, right? So half of the number will be half numbers will be total number divided by 2, right? So for this case, it's 9 divided by 2 is 4.5, right? 4.5, we probably want to plus 1 and round it down. We want our sorted array have at least 5, right? Math.floor. So if there's 5 elements, there's 10 numbers in all arrays. It means when I want to have 6, when I have 6 numbers, right? Sorted. Then we want to take the average of 2 last numbers. So 10 divided by 2 is 5. 5 plus 1 is 6, right? Which is correct. So we want to loop as long as half number is 0 greater than 0. For each iteration, gonna decrease half numbers by 1. Okay. So for each iterations, our goal is to push a number to the sorted list, right? But in order to know which number to put to sorted list, we're now using a min heap, right? Min heap is new heap. Come on. Okay, new heap. Initialize is empty, right? Compare A and B. What we wanna store here? B minus A will give us the min heap. What we wanna store inside the min heap? is probably not just the number itself. We need to remember where each number comes from so that we can add the next number to the heap, right? So it means we need to remember the current index, the subarray index, right? So for this example, L3 will be of index 2, right? And for example, we are 3, right? So our next number will be 4. So we also need to remember the current index, number index, and the subarray index, right? So we probably want to store in these informations in the heap. So how about creating a node which has all these things inside? This dot file is absolutely required. This dot array index, subarray index, right? The third one is num index, number index in that subarray, right? Num index. Okay, gonna take this from the parameters array index, num index. Okay, so it means here A and B is a node, so we want to extract the val instead. This will give us mean heap. So before before entering the loop, we want to have something in the heap. We want to have 3 first number in the heap first, right? Add first numbers of each subarray into heap, right? So it means for let array of list, right? Gonna add a list here is L1, L2, L3. This will be L1, L2, L3. This. So we iterate for every subarray. Get the first one, right? The first number of each subarray, but we want to add the node instead. So minheap.add new node. The value will be array at index 0. Array index is, we don't have access to array index here, so let's use entries instead. Let's say 3 to 4 entries. Okay, next. Okay, entries, gonna destructuring. Array index, right? So the second argument is array index. The number instead will be 0. Okay, first numbers of each array into heap. Okay, so we have or the first number in the heap now. So for each iterations, we want to pop one node out, which is min heap dot pop. Okay. The node L going to take the value and add to the sorted list, which is we don't have yet. Sorted list, sorted array, list, let's say. Okay. So for each iterations, get the node L, push the value of that node to the sorted list, and find the snack number of node L. Actually, we can destructuring this. It's an object, so we destructure the file here. We want to have the array index and num index as well. So we wanna add the next number that is come right after val in the heap, right? So what is the next number? So the next number will be let's say current array will be list dot array index, right? So the next number will be next node will be new node quad. The next node will be current array, right? We get the next index, right? The node L is of index num index, right? So the next number will be num index plus 1. The array index will be the same here. The num index will be num index plus 1. But what if the current index is the last number of one array? So we probably just want to enter here if the num index plus 1 is still less than the array current array size. Okay, if that is okay, for the next node, push the next node to the min heap. Add next node. Okay. So after exit, it means we have half the numbers inside the sorted list here. So we want to find the last number, right? So if the total numbers is odd, else If the total number is odd, want to return the last number. Return the last number, which is sorted array list. Sorted list. The length -1. Okay. Now if it is even, wanna add to last number, right? Then divide by 2. Okay, that's gonna attach. Yes, 14 2.1 2.1. Is there anything wrong here? Okay, it works, right? Okay, that's it for median of unsorted arrays. So thanks for watching. See you in the next video.